Welcome to the debate. Today, we're diving into something pretty central to infrastructure as code, the sequential workflow in Terraform. We're talking about those core commands init, plan, apply, and of course, destroy, and whether running them strictly in order is always the way to go. So the real question we're wrestling with is this. Given Terraform's power for managing infrastructure, should that strict init plan apply sequence be treated as, a universal best practice for safety, for consistency, or can we justify sometimes skipping or automating steps, especially that manual plan review, to gain speed in modern deployment setups? I'll be taking the position that yes, we absolutely need that rigor, that strict sequence is fundamental for safety, for preventing configuration drift, and it aligns perfectly with IaC principles, especially if you're learning or, say, preparing for the Terraform certification.
Okay, and I'm going to argue from a slightly different angle. While I agree that understanding the sequence is crucial, I don't think it always needs to be followed manually, step by step, every single time. I think flexibility, conditional automation, that's really necessary for actual operational efficiency, especially when you're scaling things up in the real world, assuming, of course, you've got good governance in place.
Okay, I understand the push for efficiency. I really do. But let me just double down on why this sequence is so foundational. It's not just arbitrary steps, it's engineered for safety. So first, you write your configuration, right, using HCL. Then you absolutely must run Terraform init. There's no getting around it. It prepares everything, reads your config, figures out, okay, you need the AWS provider, the Azure provider, whatever it is, and downloads those plugins. Skip init and, well, nothing works. Then comes Terraform plan. And this is where the critical safety aspect really kicks in, I think. It compares your desired state, your code, against the actual state file and tells you exactly what it intends to do. Which resources will be added, marked with a plus. Which will be changed, that's the sign. And crucially, which might be destroyed, the minus. That explicit review step is really the only reliable way to catch potentially catastrophic mistakes or configuration drift before they happen. It ensures what you have matches what you want. That's the control we seek, moving away from clicking around in a UI.
Yeah, no, that's a solid explanation of the mechanics, and you're absolutely right. You can't do anything without init, and you definitely need a plan generated. But I think we need to carefully distinguish between generating that plan and manually clicking yes to approve it every single time. The reality, especially in complex environments, real-world scaling, it just demands velocity. The goal is getting the infrastructure provisioned, and that's ultimately done by Terraform apply. Now, the source material points out that if you just run apply, it does generate a plan and asks for interactive approval. But often in automated setups, that interactive step is frankly just a speed bump. A necessary one sometimes, but often one we can engineer around. And the key tool for that is the -out flag. So an engineer, or more likely a CI system, runs Terraform plan -out equals my plan. That saves the exact blueprint of the intended changes.
Then, the apply step uses that specific file, Terraform apply my plan. It runs non-interactively. No human needed at that point in time. It lets you decouple generating and maybe verifying the plan from the actual execution. I mean, efficiency suggests that if you have a known, repeatable change, maybe going to a QA environment, it shouldn't grind the whole pipeline to a halt waiting for someone to type yes. That's why those automation flags exist, right?
I'm just not quite sold on that because I think you introduced a significant risk the moment you automate away that human review of the plan, especially for sensitive changes. That explicit lookover by a human reading the plan output, it's often the only real safeguard against unintended destructions. Let's take a concrete example. Imagine you've got a critical production database, an RDS instance. You make what seems like a tiny configuration change, maybe tweaking a parameter group setting or changing an encryption detail. Terraform might analyze that and say, I can't change this in place. I have to replace it. That means destroying the old one and creating a new one. That's potentially massive downtime, maybe even data loss if something goes wrong with the snapshot and restore. Seeing that big red minus sign indicating destruction in the plan output is absolutely vital. If you are just relying on auto-approve applied to a saved plan file, you're essentially trusting that your automation, your scripts will never misinterpret or fail to flag that kind of dangerous replacement. Professional practice, why we moved to IOC, was partly to mandate review. Skipping it feels like sacrificing control for what might be a pretty small time saving in the grand scheme of things.
Okay, I absolutely agree on the seriousness of unintended replacements. Nobody's suggesting we just blindly auto-approve everything into production. That'd be crazy. But in well-governed environments, think CI/CD pipelines, with robust checks, that plan file generated without isn't just ignored. It gets stored as an artifact. Often it's analyzed by the CI system itself. It might be posted as a comment in a pull request, requiring mandatory peer review before that automated apply job is even allowed to run. So that separation of concerns can actually enhance safety in a way. The person reviewing the plan isn't the same person nervously typing apply on the command line. They're reviewing a static, immutable artifact. And you actually mentioned it yourself, the source material talks about using plan destroy specifically to see what destroy will do before you run it.
That itself shows the principle. The review step can be decoupled from execution when you have strong processes around it. But let's maybe shift back to the foundations you brought up, the exam perspective, building that core understanding.
Fair enough. Yeah. If we're talking about building that solid base, especially for something like the Terraform Associate exam, the sequence is absolutely fundamental. It's not just init and plan. You really ought to run Terraform validate right after init. This command specifically checks your HCL syntax and the basic logic in your configuration files. It catches things like, did you forget a required argument, like a file name for a local file resource? Or is your provider block structured correctly? Skipping validate, even just when you're iterating quickly in development, well, it significantly bumps up the chance of runtime failures later during the apply. And if apply fails halfway through, you can end up with a messy situation, partially created infrastructure, maybe a corrupted state file, and then you're looking at manual cleanup or a tricky rollback. That rigorous sequence, including validate, aims to ensure correctness before you even try to talk to the cloud provider.
Okay. While syntax validation is definitely important, I think we also have to admit that the practical command sequence often depends on the context and, frankly, the maturity of your tooling. If I'm an engineer and my whole day involves making dozens of tiny iterative tweaks, maybe just adjusting variables like changing an instance type from t2.micro to t.small using a variable, or bumping up a replica count, running the full init, validate, plan, manually reviewing the plan every single time, it just becomes a drag. It slows down the development loop considerably. And we lean heavily on modern tools now, right? Like VS Code extensions that give you instant feedback on HCL syntax. Often, errors are flagged immediately as you type, way faster than running validate. And let's be honest, the ultimate test often comes when Terraform tries to actually interact with the provider during apply. That's when subtle logical errors or provider connection issues surface. Things that validate might not even catch. So the utility of a separate mandatory validation step, it kind of gets absorbed into the process, either by the IDE or by the eventual plan or apply in an efficient workflow.
But that reliance on tooling, catching things later, or relying on the apply to fail, it feels risky. It sounds a bit like fail fast is being prioritized over build correctly the first time. The whole point of the structured IaC workflow is to be proactive, to catch errors early and not reactive after things start breaking. Validate forces you to fix syntax and basic logic before involving the provider and potentially creating resources incorrectly. If you're building that foundational knowledge, like for the exam, you absolutely need to understand why validate exists and where it fits in that sequence. Skipping steps potentially just builds up technical debt that you pay for when apply inevitably fails. But okay, let's pivot to maybe the most consequential command, destroy. How do we ensure safety there if we're sometimes bypassing these intermediate checks?
That's a really critical point, and it brings us right back to the state file, the terraform.ts state file, which is, like you said, the undisputed blueprint of what Terraform manages. I completely agree. The state file is paramount. It's the map between your code and the real-world resources.
Exactly. And the sequential rigor is vital here too. Terraform destroy has to operate based on that state file. If someone, say, went into the AWS console and manually deleted a resource that Terraform thinks it still manages, that's state drift. The state file is now wrong. You really should run Terraform refresh, or at least let the refresh that happens before plan or apply run to sync the state file before you try to destroy anything else. And for maximum safety, especially with critical infrastructure, running plan-destroy first, just to see exactly what will be removed, is highly recommended. The strict sequence helps maintain that crucial state file integrity right up to the very end.
Agreed, 100% on state management being key. But it's worth remembering that destroy is conceptually just a special mode of apply. Under the hood, it's like running Terraform apply-destroy. Where efficiency really comes into play and where bypassing manual steps becomes almost necessary is with ephemeral environments. Imagine a team that spins up, say, 50 isolated test environments every day using pre-validated Terraform modules. These environments might only live for a few hours. Insisting on manual human approval for every single Terraform destroy command when cleaning those up is just not practical. The fact that the -auto-approve flag exists and is commonly used with destroy in these scenarios proves the point. While the underlying process relies on the state file and calculates the destruction plan rigorously, the strict human confirmation step is deliberately optional for known temporary resources. The safety comes from the ephemeral nature and the trust in the validated module confirmed by the state file, not necessarily from a human typing yes 50 times a day.
But that feels like a very specific use case. Temporary, ephemeral setups. That's arguably the exception, not the rule, compared to the long-lived, critical production infrastructure most people manage. For that standard infrastructure, sticking to the full sequence, init, validate, plan review, then the action, apply or destroy, provides that necessary rigor, that default safe mode that prevents really costly mistakes.
And maybe that's the crux of it, right? The overall cycle, define config, initialize, then take action, that's non-negotiable. But the necessity of manual intermediate approval steps like reviewing the plan, that seems highly context-dependent. Automation, efficiency needs, especially in scaled environments, often justify streamlining parts of that sequence using tools like plan files and automation flags, provided the governance is there.
Ultimately, I think the source material lays out a really strong foundation where that explicit step-by-step command sequence provides clarity, safety, and predictability. And that's crucial, especially when you're learning or when you need to maintain very strict control, adhering to core IaC principles.
Yeah, and while that foundation is key, Terraform itself provides the tools, the runout flag, the auto-approve, precisely so that experts can adapt that sequence for specific real-world needs. It allows balancing that essential rigor against the operational demands for efficiency. So both viewpoints have merit, and it really leaves it to the engineer in their specific situation to decide exactly where on that spectrum between absolute safety and maximum speed they need to operate.